Good morning. Welcome back to the stoichiometric equations lesson 7. Yesterday we have already seen the redox reactions, many transformations like addition of oxygen, removal of oxygen, addition of hydrogen, and so on and so forth, electronegative element and all these things. Continue to that. So here are some of the redox reactions. Sodium plus chlorine gives sodium chloride, sodium plus oxygen gives sodium oxide, sodium plus sulfur, sodium sulfide, sodium plus hydrogen, sodium hydride. All these reactions are this thing only. If you see the first reaction, sodium and chlorine, it is sodium chloride, sodium is oxidized, here also sodium is oxidized, here also sodium oxidized. Now today furthermore we are going to classify the redox reactions are easy. But here we will start with redox reactions in terms of electron transfer. How we can represent are easy. Finally, all the equations or problems is to be solved in easy way. So we will see this. Now first reaction I am taking sodium plus chlorine equal to sodium chloride. I will write in the two half cells way. Sodium gives sodium plus 2 electrons is 2 sodium plus gives 1 sodium is giving 1 electron. This is one half cell. Another one chlorine. Chlorine is taking the 2 electrons, gives the chloride, 2 chloride. If you combining both equations, electrons cancel. Sodium plus chlorine, the same equation will come. Sodium 2 sodium plus chlorine gives sodium chloride, Na plus Cl minus 2. That is chlorine. I am cutting down the both electrons. This is the electron transfer method. So it is nothing but oxidation of the sodium and the reduction of the chlorine. Okay. If you see, this is the first reaction. The second reaction you say, take again 4 sodium gives 4 Na plus 4 electrons and O2 4 no sorry Na2O yes 2 Na 2 electrons 2 Na and O2 plus electrons 2 electrons gives O2 2O, that is O2 minus Na2 2O minus. So combining these two equations, again you will get two Na plus O2 Na2O. Similarly, the sodium and sulfide. But in the last reaction, there is slightly a difficulty. We will see later. So in this, oxidation and reduction as at a time we can express. Now sodium is oxidizing and chlorine is reducing. But at the same time, we will define like this. Oxidation means, from the electron theory, oxidation means loss of electrons. Number 1. Loss of electrons is oxidation. Reduction is gain of electron or by species, by atom or what is. This is oxidation, gain of electrons. Now oxidizing agent, one more we are defining. Oxidizing agent is the reverse. One who is gaining electrons is oxidizing agent. Acceptor of electrons. Acceptor of electrons is oxidizing agent. Similarly, reducing agent. Reducing agent is donor of electrons. These are the some of the laws. Now, there is a competitive electron transfer equations, particularly for the Daniell cells, galvanic cells, and all these things that will deal separately. Now, one more concept will start, that is called oxidation number. Oxidation number. In the oxidation number, one assumption, small assumption we are taking, that though non-ionic equations or covalent compounds also electron transfer is taken place. That is assumption. It is only for the bookkeeping purpose. Nothing is actually happening. It is a covalent compound only. Don't get the confusion. Covalent compounds, but for the easy to understand, the electron transfer is completed. Actually, the covalent compound is sharing. Even though it is sharing, but it will be towards the two electronegative atom. But we are considering here it is electron is transferred, not shared, transferred, just for the understanding purpose. Okay. What is that? The oxidation number. Oxidation number denotes. It denotes oxidation number. It denotes what it is denoting. The oxidation state of an element. The oxidation state of an element in a compound. But there are a set of rules.